So I've mentioned dynamic power a couple times now, and I'm going to go into challenges of running these different tests, but I think we need to have a little bit of an understanding of why dynamic power is different. And I have a single graphic that I think illustrates this really well. So when we're running these drive cycles, our speed is constantly increasing, decreasing, starting, stopping. We get this profile. Why is this different than a steady state measurement? Well, when a motor is started, stopped, or changes state, there are losses associated with that state change. And rather than tell you through words, I think this picture on the right-hand side does a really good job of explaining it. So we have a machine, it's spinning at a certain speed, and then we apply a load to it. And what I have on the screen here is just a single phase of current, because a single phase of current illustrates my point. And we can see we have no torque, so we have no current, and then we apply a load. And we can see we get this really kind of big spike. We get these peaks on current. What is this? This is an inrush current. This is a loss associated with dynamics. And then we can see that current settles out to kind of a steady state operation point. Okay, why do I care about this? Well, if we look at our power, reactive power, apparent power, we can see when we get that inrush current, we get this spike in real power in black, and then our reactive and apparent power in pink and red. These are losses, because as that machine is settling out, we can see that go down to a nominal level. But we have this additional loss in that transition period. And if we're not measuring this signal correctly, we're going to miss all of this. We're going to miss all that additional loss. So when we go to do our component level test or we go to understand the vehicle level test, we're missing these dynamics. That's no good. And these losses are constantly there in a drive cycle. And we need to characterize these dynamic losses so that we can get a decent measurement and really understand how to improve our components. So when I talk about dynamics, this is what I'm talking about. And in a moment, I'll talk about how HBK measures these quantities really well. We have this little black square wave. This is a thing we call cycle detect. This allows us to measure these dynamics really well. We'll speak on that more in a moment. Okay, dynamics have additional losses. We're running these drive cycles. Drive cycles are constantly dynamic.